Hello everyone, welcome back to another kinetic tutoring episode. Today we're taking a look at yet another AP Physics C Mechanics FRQ problem. So let's get straight into it. A ball of mass m is thrown vertically upward with an initial speed of v initial. It experiences a force of air resistance given by force is equal to negative kV, where k is a positive constant. The positive direction for all vector quantities is upwards. Express all algebraic answers in terms of m, k, v initial, and fundamental constants. And part A asks, does the magnitude of the acceleration of the ball increase, decrease, or remain the same as the ball moves upward? Alright guys, so let's just first write out our force equation. We know that our net force, F net, is going to be the force minus kV, which if we draw the free body diagram, ball is going upwards, so the air resistance is going downwards. And we also have gravity going downwards, minus mg. So both of these forces are going towards the ground or in the negative direction. So we can write that ma, because ma is equal to F net, is minus kv minus mg. And therefore, our acceleration is minus kv minus minus kv over m minus g. So there we have that. We have an equation for our acceleration. We know that k and m are constant, and so is g. So only thing that is a variable is our velocity. And if we think about a ball going up into the sky, thrown up into the sky, we know that its velocity is going to decrease. Therefore, the magnitude of the acceleration is also going to decrease as the ball moves upwards. So there goes the answer for that. Write but do not solve a differential equation for the instantaneous speed v of the ball. All we have to do from here is turn a into dv dt. And this is because acceleration is simply the change in velocity over the change in time. Negative kv over m minus g. So there we have that. C says determine the terminal speed of the ball as it moves downwards. In order to do this, we know that the terminal speed is when the acceleration reaches 0. So we can say that we know that our acceleration is going to be 0. And therefore we can move this g over. G becomes negative kv over m. And the terminal speed is velocity, so we're going to get velocity by itself. It'll be negative mg over k. So there we have that. That is going to be the terminal velocity, negative mg over k. D says, does it take longer for the ball to rise to its maximum height or fall from its maximum height back to the height from which it was thrown? Alright guys, so let's take a look at the forces. When the ball is going up, the F net is negative kV minus mg. But when the ball is going down, it's going to be positive kV minus mg. Because as the ball is going down, air resistance always moves in the opposite direction of the object. So as the ball is going down, air resistance is going to be going upwards. And seeing this, these two forces contradict each other, whereas these two forces add to each other and make the magnitude greater. Therefore, the acceleration of this force is going to be greater, meaning that this is going to take a shorter time to happen. Therefore, it's going to take longer to fall. On the axes below, sketch a velocity versus time graph for the upward and downward part of the ball's flight, where TF is the time at which the ball returns to the height at which it was thrown. So we know that the ball starts at this height here and ends here. And since we find out that it takes longer to fall, the maximum height, or the maximum, rather, I did that wrong. I was thinking about the position. So it starts at the maximum velocity and it ends a little bit less than the maximum velocity because the air resistance is not a conservative force, meaning some of the velocity is going to be lost. And we know that when the ball reaches the top of its arc, its velocity is 0. So at some point here, the velocity is going to switch directions. And since we found out that it takes longer to fall, it's going to be before this midway line. So we can just say anywhere before this midway line, for example, here. And from here, we can just draw our line. You can just put a rough graph. Make sure what is important to do is signify that the velocity at the beginning is greater than the velocity at the ending because some energy is lost due to the air resistance. Make sure to signify that it goes to 0 because as the ball goes up and then down, it's changing directions, and in order for it to change directions, the velocity needs to reach 0. And the final thing is that it reaches 0 before the halfway point in time because it takes longer to fall than it does to rise. Alright guys, that's all I have for you today. Hopefully you learned something. Hopefully this was helpful. If you have any further questions, make sure to leave them in the comments below and I will be happy to answer them and sort out any confusion to the best of my ability. Have a great rest of your day and I'll see you guys next time.